Welcome to the Math Channel. In this episode, I'd like to show you the quickest and easiest way to factor and solve quadratics. So let me give you an example. If we have 6x squared minus 5x minus 4, now we've got a leading coefficient of 6. Now, if you were to do this another way, you might have to use the box, and there's another method called the AC method. This method almost leads to no guess and check and no confusion. You just go straight down to the answer. So I'll show you how it works. What we do is we multiply the 6 into the constant term. Okay, so what we get a new quadratic, x squared minus 5x minus 24. Now this quadratic is much simpler to factor because the leading coefficient's 1. So we write our two factors, and all we have to determine is what are the factors of negative 24 that add up to negative 5. So here they are, all the factors of 24, which combination can give you a negative 5, and that's the 3 and the 8. So what we write is x minus 8 and x plus 3, okay, gives us x squared, positive 3x, negative 8x, and a negative 24. Now here's the part to this method that you may find new. What we do is we put this leading coefficient back into each factor. 6 there and a 6 there. Now remember, we put 1 6 into the 4. Like we multiplied the 6 times the 4, and we're putting 2 6s back into this expression. So in other words, we have one too many 6s. We need to factor out the extra 6. And we do that by taking out the GCF of each factor. So if you take out the GCF of this factor, which is 2, we're left with 3x minus 4. If we take out the GCF of this factor, which is 3, we're left with 2x plus 1. Now this 2 and that 3 are the extra factor of 6 that we put in. So it's extra, meaning it wasn't supposed to be there in the first place. And 3x minus 4 times 2x plus 1 is the factored quadratic. Okay, so we're going to do another example just in case you kind of missed the flow of the first one. And so let me give you another quadratic with a leading coefficient other than 1. Okay, so again, the first step is that we're going to multiply our leading coefficient, and we're going to multiply it by the constant term, and we're going to rewrite the quadratic. X squared plus 3x minus 18. Okay, now again, this is an easier quadratic to factor because the leading coefficient is 1. All you need to determine is what are the factors of negative 18 that add up to 3. So here they are. What pair of factors multiply to negative 18 and then add up to 3? And you can see that 6 and 3 is that pair. So we have x and x will give us our x squared, a plus 6 and a minus 3 will give us a positive 3x and a negative 18. So again, here's kind of that trick to it. You have to put the 2 back into each factor. So put a leading coefficient back into each factor, and then we just take out the GCF of each. So with this first factor, we can take out a GCF of 2, and we're left with x plus 3. Now the second factor this time doesn't have a GCF. We only put in 1 extra 2, and we already took it out. So this factor remains the same, and so that's our extra 2. And your final answer is x plus 3 times 2x minus 3. All right, so I'd like to do one more example, and then I'll post up a few questions and the answers. That way you can get a chance to just try it on your own. So this time we're going to start with a leading coefficient of 10, so 10x squared plus 11x minus 6. Okay. Again, we're going to multiply the 10 by the constant term, and we get a new quadratic with the leading coefficient of 1. Notice our middle term always stays the same. Now we're going to factor this quadratic. Now remember, the first term in each linear factor is going to be x because our leading coefficient is 1. Now we need to find all the factors of negative 60, or factors that multiply to negative 60 that also add up to 11. So again, here's all the factors of negative 60. We just need to pick the right pair. And in this case, we need 15 and negative 4. So we have a positive 15. We have a negative 4. We're going to put our 10 back into each factor and then take out the GCF. So the GCF of 10x and 15, that's 5, and you're left with 2x plus 3. The GCF of 10x minus 4 is 2. So that's 5x minus 2. And again, this 5 and 2 represent the extra 10 that we put into the problem. We had 10, we put it into the 6. We put 2 10s back into the as in front of x. We only are supposed to have 1. So this 5 and 2 are extra, and our final answer is 2x plus 3 and 5x minus 2. All right, next I'd like to show you how you'd use this method if you're going to solve the quadratic after you factor it. And I mean, essentially you could do it the same way, but I'm going to show you almost another shortcut within this shortcut. It's going to start out the same way. We are going to multiply the 6 into the 12. Okay, and we get our new quadratic, x squared plus x minus 72 equals 0. We're going to factor this new quadratic with the leading coefficient of 1. We need 2 factors that multiply to negative 72 and add up to a positive 1. So here's your list. Determine which pair makes negative 72 and adds to 1. Okay, and in this case, we need a positive 9 and a negative 8. Now here's where things change slightly. We're going to use the zero product property to solve this quadratic, which means we're going to set each factor equal to 0 and solve. We'll do that. X plus 9 equals 0. Or x minus 8 equals 0, and we'll just solve both. We can take away 9 on both sides and get x equals negative 9, and we're going to add 8 to both sides and get that x equals 8. Okay, but our answers are not negative 9 and 8. Remember, we took the leading coefficient of 6 and we put it into the negative 12, and so these are our answers without that leading coefficient. So essentially all we need to do is put our leading coefficient back and then reduce. So x equals negative 3 halves, or x equals 4/3. Okay, I want to show you why that last step worked, how we can just put the leading coefficient back into the denominator of the answer. And here's why. Remember when I showed you that you put the leading coefficient back into the x of each factor? Well, imagine we did that. We put the 6 here, and we put the 6 there. Okay, so then we'd have 6x plus 9 equals 0, and 6x minus 8 equals 0. Now if we solve for x in these cases, we get minus 9 on both sides, 6x equals negative 9. Now we just have this extra step at the end of having to divide by 6 to get x by itself, and we're still going to end up with x equals negative 3 halves. Okay, so on this side, we add 8 to both sides. 6x equals 8. Again, here's just that step we're kind of taking out. Divide both sides by 6. And now x equals 4/3, which is the same thing we got up here. We just didn't put the 6 back in and put it in at the very end. All right, so now I'll show you another example where we just work straight through without too much explaining, so you can see it. Start with 2x squared plus 13x plus 20 equals 0. Okay, so again, we're going to multiply our leading coefficient by the constant term and rewrite our new quadratic. X squared plus 13x plus 40 equals 0. Now we're just going to solve this one and then put the 2 back in to each solution. Okay, so we factor x and x. We need 2 factors that multiply to 40 and add up to 13. Okay, in this case we can use 8 and 5. So positive 8, positive 5. Okay, and here's where we use that zero product property. If two factors multiply to 0, then one of these factors has to be 0. Either the x plus 8 has to be 0, or the x plus 5 has to be 0. And now we just quickly solve for the x. Take 8 away from both sides on this side. Take 5 away from both sides in this equation. And we get x equals 8 and x equals negative 5. But remember, these are the answers without that leading coefficient put back in. So we take the 2 and we put it back in. This one can be reduced to 4. This one cannot be reduced. So there's the two solutions. All right, next I'm going to post up a few questions that you can try to solve and factor on your own, and then I'll post up the answers in a few moments. So you can just pause the video, do a couple of quadratics, and then check out your answers after that. Thanks for watching this episode on the Math Channel. Remember, if you enjoyed this video, please like it. If you have any questions, go ahead and post them in the comments, and I'll see you next time.